All right, Honors Chem, today we are going to talk about hydrolysis. And we probably don't really have an idea of what hydrolysis means. So let's break down this word. In Greek, what does hydro mean? Do you remember? It means water. And lysis, that means to cut or to break. So we are going to be cutting or breaking water. Okay, so this is to cut or to break. So hydrolysis is just a fancy way of saying that we can break water apart. And you'll notice that we do this already into the hydrogen ions and the hydroxide ions. And we can do this pretty readily just in normal water, but we can really do it with different ionic compounds or salts. So some salts, remember, salts are just ionic compounds. So some salts can actually affect the pH of the solution when you dissolve them into the water. Okay, so let's define hydrolysis really quick in terms of the chemistry definition. Okay, so hydrolysis can react with water, some salts. So some salts will react with water to produce excess hydrogen ions or sometimes excess hydroxide ions. So we have a solution that when we dissolve a salt in it that produces excess hydrogen ions, we're going to have an acidic solution. Or if we have a salt once that produces excess hydroxide ions when it is dissolved in solution, that solution is going to end up being basic. Okay? So for this, it's super important that you know all your strong acids and all your strong bases. So let's go over those acids really quick. So our strong acids, we have three binary ones. We have hydrochloric, hydrobromic, and hydroiodic. And then we actually have four ternary ones. We have sulfuric acid, nitric acid, perchloric acid, and we also have chloric acid. Okay? For our bases, we have all our group 1 hydroxides, so lithium, sodium, potassium, rubidium, cesium hydroxides. And then we also have barium, strontium, and calcium hydroxides that are strong, that will dissociate or ionize really quickly and really completely. Okay? So let's go through this piece by piece, and we're going to talk about salts that produce neutral solutions right now. Okay? So salts that produce neutral solutions have they have negative ions. So they have anions, or the negative ions, that come from strong acids, and they have cations, or the positive ions, that come from strong bases. Okay, so to have a neutral salt, both the anion and the cation have to be conjugate acids of strong acids or conjugate bases of strong bases. Okay, so let's give you an example really quick. Well, actually, we're going to define salts that produce basic solutions. So if I have a salt that produces a basic solution, they have anions that come from weak acids. They have anions, or the negative ions, that come from weak acids. I can't spell today. Okay, so the conjugate acid is gonna, or the conjugate base is gonna have to be very, very from a weak acid. Okay, and then salts that produce acidic solutions have cations or the positive ions that come from weak bases. Okay, so let's give you some examples really quickly on all of these. So now that we've got them defined, let's give you some examples. So I'm going to give you a neutral salt here really quickly. So sodium chloride is a neutral salt, and let's see why it's a neutral salt. So let's just take the various ions. If I have sodium and I have it react with water, and we're going to think of water as HOH here, okay? What part of the water molecule is the sodium going to be attracted to? Is it going to be attracted to the hydrogen or to the hydroxide? Hopefully you said hydroxide because negatives and positives attract. So when we do that, we would expect to make sodium hydroxide and hydrogen. We know that this is a strong base, so that this will dissociate. So that is a neutral reaction because it really doesn't stick together. It will dissociate into its various ions. So it doesn't stick together. Let's look at chloride ion. When it reacts with water, and once again, we're going to think of water as HOH. What part of the water ion is the chloride ion going to be attracted to? It's going to be attracted to the hydrogen. So it would make hydrochloric acid and hydroxide. Now this is also a strong acid. So it is not going to stick together. It is going to dissociate completely. So because it dissociates completely, this is also neutral. Okay? So because both of these end up being neutral, the salt overall ends up being neutral. Okay, let's do an example with base. Okay, so basic salts. Let's look at sodium fluoride. Okay, once again, we're going to break these ions up and see what they look like and react with water. So sodium, if I react it with water, we would think that it should make sodium hydroxide, and we would end up with hydrogen ions. But we know that this is a strong base, so that is a neutral reaction right there. And then if I have the fluoride ion and I react it with water, we know that it would react with the hydrogen end of that water and make hydrofluoric acid, which we know is weak because it's not hydrochloric, hydroiodic, or hydrobromic. So we know this is weak. This is going to stay together. And because it stays together, that means that we are going to have excess hydroxide ions in solution because the hydrogen ions that water normally makes when it ionizes are going to be taken up by the fluoride ions. And so the hydroxide ions are going to be in excess. So this is going to make it a basic solution when we dissolve that salt into water. Okay, now let's look at an example for acidic solutions. So if I have zinc chloride and I want to dissolve that, let's think about zinc. Zinc is a positive 2. So I'm going to have 2 waters here for it to Positive 2 is going to react with the 2 hydroxides, right? So I will make zinc hydroxide and 2 hydrogens. Now, is zinc hydroxide a strong base? Is it a group 1? No. So is it strontium, barium, or calcium? No. So that is weak. So that's going to stick together, and that's going to leave us excess hydrogens. Let's look at the chlorides. If we have water, we're going to make hydrochloric acid and a hydroxide. This is a strong, so this is a neutral reaction right here. So in total, we're going to have excess hydrogens. So this will be an acidic solution because we will have excess hydrogens. Okay? So the question then becomes, what if the salt contains both a cation and an anion that hydrolyze? So if we look at ammonium, it's going to get together with water and make ammonium hydroxide, right? And a hydrogen. So that's weak, so that's going to stand out. And then fluorine, we just done fluorine, and it will get together with the hydrogen fluoride and create hydroxide ions that stand out. So which one is more powerful? What you really have to do is you have to look at the dissociation constants of both the acid and the base. So the dissociation constant for the acid is 5.6 times 10 to the negative 10. And the dissociation constant for the base is 1.4 times 10 to the negative 11. You really got to look at which one is the larger number. So if we look at this, the one with the larger number is the dissociation constant for the acid, for the ammonia. So we know that that one's actually going to overpower. So we know that because the Ka, or the dissociation constant for the acid, is bigger than the dissociation constant for the base, this is going to end up being an acidic solution. So we're going to say that would be acidic. But you'd have to look at, because the Ka, or the dissociation constant of the acid, is larger than the Kb, that is going to be more powerful. So because the acid is more powerful, this would be acidic. Okay, so let's look at some of these examples, and we want to decide whether this is acidic, basic, or neutral. Okay, so I'll do the first couple with you, and then we'll see what we do. Okay, so sodium. Let's do sodium. Reacting with water, it will make sodium hydroxide and hydrogen. That's neutral though, right? That's not a reaction because it's a strong, right? That's a strong acid. Chloride plus water will get me hydrochloric acid plus hydroxide. That's also not really a reaction because that's also a strong. So because both of these are not reactive or neutral, this is a neutral salt. Okay, let's do this next one. So I've got potassium reacting with water. I will make potassium hydroxide, which is a strong acid, or a strong base because it's a group 1, and hydrogen. So that is not really reactive. Let's look at, I don't want the header on here. Let's look at acetate plus water. We will make acetic acid, which we know is a weak acid. So that will stay together, right? And hydroxide. So we will that actually produces excess hydroxides. So this is going to be a basic salt. Okay? All right, I want you guys to do the rest of these. And let's check in a couple minutes. So pause the video and take a gander at this. All right, you ready to check? I'm going to show you a little shortcut just to help you figure this out a little bit faster. Instead of writing out all the equations, I just write out what the acid or base would be and determine whether it is weak or strong. So sodium hydroxide is strong, right? Hydrofluoric acid is weak. So that means we have a strong base. So if I have a strong base with a weak acid, I'm going to have a basic solution, right? Whatever's strong is going to overpower it. So this is going to be basic. Okay, let's look at this. Ammonium hydroxide, that is weak, right? And I've got hydrochloric acid, which is strong. So I am going to have a whole lot of excess hydrogens. Yep, you're right. So because I have a strong acid, this is going to be acidic. Okay, how'd you do on that one? Then aluminum. Aluminum is a +3, so I'm going to need 3 hydroxides to balance that out. That is a weak base. Okay, and chloride we've already done. Hydrochloric acid, that is a strong acid. So this is going to be pretty dang acidic because the acid is much stronger than the base. Okay, and let's do potassium nitrate. So potassium hydroxide, that is strong, and nitric acid is also strong. So they are both strong acids and bases, so this will be neutral. How'd you guys do on that? All right, so now you know how to do hydrolysis. Have a great day. We'll talk to you later. Bye.